Good morning, everybody. I just thought I'd send a quick video out to show you how we would teach equivalent fractions. Also for the children, this is a lesson you can work through. You can follow the slides. You can pause it as we go through and just have a go at the different types of questions. But hopefully, I'll be able to model how we might use sentence stems, so how children can explain their learning, and also how they can show good mathematical thinking as we go through as well. So this is all on equivalent fractions. And as our friend here says, are you ready to master equivalent fractions? So firstly, we've got some representations here. So we start by looking at these two representations here. And you can see that the whole has been split into two parts. Here, the whole has been split into four parts. So this says what fraction of each shape is green? So all we need to do is look at the whole shape. And as we can see, half of the shape is green. So we would say 1/2 of the shape is green. Now you can see the same size whole here. This shape has been split into four parts, or equal parts. This time, 2 of the parts are green. So 2 out of the 4 parts are green. But we're not going to say 2/4. We're going to say 2/4, because when a shape has been split into 4 parts, we say it's been split into quarters. And we can see something similar here with these two circles. So we've got the whole, it's been split into 2 parts. One part is green, so 1/2 is green. And here we can see the shape has been split into 4 parts. 2 parts are green, so 2/4 are green. So you might say to your family, your mums and dads, whoever's helping you with this first shape, the fraction is 1/2. With this shape, the fraction is 2/4. This shape, the fraction is 1/2. This shape, the fraction is 2/4. So let's revisit what we should know already. Now this is a sentence stem written here. And the first thing is I'm going to say it nice and loud, and then in a moment you'll repeat back. So 1/2 is equal to 2/4. And we can see that on the representation here. So we've got a whole split into a half and 2/4. And these 2/4 are equal in size to the half. So we say 1/2 is equal to 2/4. Now it's your turn. You say. Perfect, well done. And we all say it together. Here we go. 1, 2, 3. 1/2 is equal to 2/4. Well done. Good stuff. Okay. So let's learn now. This is quite common to look at in school, and also when you're learning about fractions, this is what we call our fraction wall. And what this does is it shows us the different sizes of fractions, but also it shows us which fractions are the same size as each other. So the top bar here, in yellow, this is our 1/2. The blue bar is also 1/2, but this one has been split into 1/2 and 1/2. So 2/2 make the whole. This yellow bar has been split into quarters. 1, 2, 3, 4. And the purple bar has been split into 8 parts, 8 equal parts. Now, when we say equivalent fractions, equivalent means equal to. So when we say equal to, we mean they are the same. So it might be the same size or the same value. So I've got some missing numbers here. How many 8s are equivalent to how many quarters? So the first thing is I'm going to say the sentence, and then you're going to copy. So to do this, what I need to do is think of what fraction I'm comparing. Now here I'm comparing 8s with quarters. So how many 8s are equivalent to how many quarters? So we can see this is not quarters, this is quarter. So we're going to look at this 1/4 here. And below it, we've got our eighths. So how many eighths are the same as 1/4? I can see here there are 1, 2 eighths are the same as 1/4. So my sentence is going to be 2 eighths are equivalent to 1/4. 2 eighths are equivalent to 1/4. Your turn. Off you go. And let's all say it together. 1, 2, 3. 2 eighths are equivalent to 1/4. And we can compare lots of different fractions just looking at this fraction wall. We can see here that 1/2 is equal to 2/4. 1, 2. You can also see that 2/4 is equal to 1, 2, 3, 4 eighths. So fraction walls are great, especially when we're comparing the sizes of fractions. So equivalent means equal to. So this one's slightly different, and we've actually just done it there, so I'm going to say it this time. So I'm going to say something a bit different. I'm going to say 1, 2, 3, 4, 5, 6. 6 eighths. So 6 eighths are equivalent to how many quarters? I wonder if you could pause the video here and have a look. How many quarters are equivalent to 1, 2, 3, 4, 5, 6 eighths? Pause the video, have a look. Okay, so we've got 1, 2, 3, 4, 5, 6 quarters, 6 eighths are equivalent to, and we can see here that we've got 1, 2, 3 quarters, which goes to about here. So our sentence is 6 eighths are equivalent to 3 quarters. Now you say, and let's say it together. 6 eighths are equivalent to 3 quarters. Okay, so something for you to do now is to pause the video and have a look at this question. So how can we use those stem sentences to compare the fractions using this fractional wall? So as you can see, we've got fraction the whole, we've got one whole. This bar, however, has been split into thirds. This bar has been split into sixths. So pause the video, try and compare two fractions using our stem sentence. If you need reminding of it, it was, say the fractions are equivalent to, and then another fraction. So for example, I might say 1/3 is equivalent to 2/6. Be careful with how you say sixths. It's quite hard to say. All right, pause the video, have a go, see what other fractions, equivalent fractions you can spot. So how does this fraction wall link to the last one? Well, this one's slightly different. So the bars here have been split into thirds and sixths. However, on the previous one, it was halves, quarters, and eighths. And that's really important when we're comparing fractions. You can get fraction walls where it lists all of the fractions. However, for this, we can see that a third can easily be split into 2/6. And we can't do that with quarters, for example. Okay, little challenge for you to think about is to think about how does this diagram, this picture, show 1/2 and 4/8. So think about how this diagram shows 1/2 and 4/8. You can pause the video here if you want. Okay, so we've got 1/2. Now, if we were to rearrange these, and if, for example, we swapped this purple part with this yellow part, and we swapped this purple part with this purple part, we would have 4 purple parts here and 4 yellow parts here. And we can see really easily there and really clearly that we'd have a half purple and a half yellow. But this diagram does also show us 4/8, because altogether we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. 4 of them are purple. So we could say 4/8. So to recap, this diagram shows us 1/2 and 4/8. And remember, we can also say that 1/2 is equivalent to 4/8. As a little challenge, maybe look at the two parts of the fraction, so our numerator and our denominator. Maybe think of the link between 1 and 4 and between 2 and 8. Just something to have a think about. Okay, something else you can use to compare fractions and look at if they're equivalent or not is to use a number line. Now, when we're using a number line, we have to look at it between 0 and 1. And as you can see, we've got it split into different fractions. So firstly, in the middle, we've got our half. Halfway between 0 and 1 is a half. We've also got our quarters. 1, 2, 3, 4. So we've got 1/4, 2 quarters, 3 quarters, and this will be 4 quarters. Underneath, we've got it split into eighths. So we've got 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and the whole would be 8/8. So pause the video. Can you use this to find any equivalent fractions? Do any of the fractions overlap at any point? Well, if I'm looking at this, I can see that 1/4 is equivalent to 2/8. I can see that 3 quarters is equivalent to 6/8. I can also see that 1/2 is equivalent to 2 quarters and 4/8. And just a little side note here, what's interesting is if you divide the denominator by the numerator, you get 2. 4 divided by 2 is 2. 2 divided by 1 is 2. 8 divided by 4 is 2, because actually we're halving. We can also see things here that are non-examples. So for example, we can see that there are no equivalent fractions here to 1/8, 3/8, 5/8, and 7/8. I wonder if that has anything to do with the fact that these are odd numbers for numerators. Something to think about. So number line is also really good for comparing fractions as well. But remember, the parts must be equal. Okay, so last thing to think about is have a look at these pictures, and this is just something for you to challenge yourself to, is to think about which of these shapes represent 2/3. This is quite a tricky task. What I would suggest doing is looking at how many parts the shape has been split into. Look at how many parts are either purple or another color, and then see if any of those fractions are equivalent to 2/3. You might want to go back to this here where we have our 1/2/3. So you can use this fraction rule to help you as well. Okay, hope that was useful. Thanks very much for listening. If you've got any questions, feel free to drop me a message on Class Dojo or in the comment box here, and let me know how you get on with this final task as well. Thanks.